Hello everyone, welcome back to my channel. Today let's go over another medium database question that I just solved on my own. So I'm really proud of this and I'm really glad that I was able to come up with my own solution to this question without any help. And I thought it was very straightforward. As long as you follow the instructions, you'll probably be able to do it. So let me show you how I did it. This one is called Find Stores with Inventory Imbalance. I think this is actually the latest question on Leetcode so far. So let me show you how I did it and let's go over it. So basically what they're asking you to do is to write the solution to find stores that have an inventory imbalance. You just have to follow each step, as I said. So first, try to identify the most expensive product. So basically, we look at the store IDs and we look at the price to identify the cheapest and the most expensive product. So let's go ahead and create a default dictive type list and use the store ID as the key in the inventory table. So for I, let's just call this V and enumerate inventory store ID. So the store ID is going to be the key, and then we're going to append each of the prices for that store ID. And then obviously we're going to sort it as well. Let's loop through our dictionary. Cool. So now we have all the prices for each store ID. So we have the cheapest and the most expensive. So let's go ahead and see that we only care about stores that have at least 3 products. So we can go ahead and say this right away. If length of DK is bigger than or equal to 3, then let's print it. And the imbalance ratio, okay, let's go step by step. So the most expensive and its quantity. So the cheapest and expensive is going to be DK of 0 and DK of -1 because we already sorted this list, right? So the smallest on the left side, the largest on the right side. And then now let's go ahead and calculate the quantity of the most expensive product and the cheapest product. So basically that's going to be the quantity of, and also we care about the price as well. So let's go ahead and take care of the quantity first. So that's going to be the combination of the store ID and the price, because we're looking at the cheapest price and the most expensive price for each store ID. So let's go ahead and say Q is a dictionary because they're going to be unique, right? So the combination of these two columns are the primary keys, and we can just say Q of, so the store ID and then also the price together. We want to record the quantity. So inventory quantity of I, which is this column, this value for this and this combined as the key. And then now we want to compare the cheapest quantity and the most expensive quantity. So there's an imbalance if the most expensive quantity is less than the cheapest quantity. So if Q of K, so K is the store ID, because that's how we set up both dictionaries as the key, and then also the quantity of the most expensive one. So, well, this one we can just say if Q of, because the expensive is the price, is less than Q of K and cheap, then we can go ahead and say there's an imbalance. So inventory imbalance, let's call this IB, is going to be the cheapest quantity divided by the most expensive quantity. So that's just going to be so here the cheapest quantity. So okay, we can just say we also want to round it to 2 decimal places. So let's say round to, we just want to take Q of K cheap divided by Q of k expensive, as it says here, cheapest quantity divided by most expensive quantity, and then round that to 2 decimal places. Let's print IB. Why is this? Oh, this is supposed to be brackets and then a tuple inside instead of tuple brackets. Oh, sorry, V instead of S. I was thinking of something else. Okay, cool. So now we have our IB. We now have to just gather all the results and put them into an answer array, because we want the store ID, which is this, and then the store name and the location, and then okay, so now we have the first and the last answers, which is the imbalance, but we want the name, the location. So the name and location are here, and then the most expensive and cheapest products are here. So let's just call this name, and let's just say name of V is equal to, let's get the store name. For IS in enumerate stores, store ID, name of S is equal to stores, store name of I, and then stores, store, well, location of I. And let's make this just a list. And now it makes it easy because we can just use the store ID, same here. So we can go ahead and print the store ID and then the store name, which is name k of 0, the store location, which is just name k1 as we just defined. And we're still missing some information, which is going to be the most expensive and the cheapest product. So okay, so again, I think we can also, let's just make another one called the product name. And again, PN of the store ID, and then the price, because we care about the cheapest and most expensive price. So that's going to be the combination of the primary key, 2 columns together, are equal to the product name. So inventory product name of I. And then we can just get the cheapest, the most expensive, and then the cheapest. So most expensive would be PN of K, and I think it's expensive. And then PN K cheap for the cheapest. Let's print this. Okay, awesome. So it looks like we have all our results, and we just have to sort them now. Let's gather it first. So answer.append K, name K0, PN, just gathering all this stuff. Name K1, and then IB. And then obviously here we want to sort by the imbalance ratio in descending order. So that's going to be -x, -1. So the last element, and then by the name in descending order. So the name is just going to be Oh, store name. So x1, right? The second element. Let's print answer. Three, city, Los Angeles. Okay. So 3, city center. Looks like we got this messed up a little bit, so we want the location. Yeah, we got this messed up a little bit. Let's go ahead and just gather them correctly. So the store, this, the location. Okay, so let's see. So we have the location. Where is that though? So location is here. Let's move this. So zero, and then here. And then after this, we can do these two. And then we can do the imbalance. Right? Okay, cool. So now they're at least gathered together. 2 Summer Mall, Chicago, phone case 25. Cool. So now we just have to sort it correctly, which is again by the imbalance ratio in descending order, and then by the store name in ascending order. That looks correct to me. If it's in descending order, then yep, negative x 0, 1, 2, 3, 4, 5. Perhaps like this. 3. Why is it 2, 1 instead of 1, 2? Sort it by imbalance ratio descending, and then by the store name in ascending order. Yep, that's correct. Yep. Imbalance ratio, yep. Yep, it's supposed to be descending order. And then by the store name. Maybe instructions are not clear. I don't know. So but then yep, that's right. Three, two, one. Yeah, this question has kind of a lot of requirements. Name K0. Yep. This is in descending order, yep. You know what? It's probably easier to do it like this instead. I don't think this wants to cooperate, so we're going to have to do it like this and then just reorder it again. Let's do it like this. And then x2, because that's 0, 1, 2. 43. Nope, that's not right. Why is this not sorting how I want it to sort? Please cooperate. Imbalance ratio. Yep, imbalance ratio. And then by the name. What the heck? Yep, imbalance ratio is rounded. Cheapest or most expensive product. Oh, okay. So I still don't understand why it's not sorting like this. Three, two, one. It's fantastic. Need you to do. Want you to do. Name K0, name K1, PNK experience. Expensive, cheap, IV. Yep, IB is what? Cheapest quantity divided by most expensive quantity. Expensive quantity is less than cheap quantity. At least 3, yep. Ordered by imbalance ratio in descending order. Yep. Store name in descending order. What? Store name. What is that? Suburb Mall? Maybe let's try just store name. Okay. I mean, that looks better to me, so let's go ahead and do this. 2, 3, 4, 5. For A, an answer. 1 dot append A0. And then just declare an empty data frame as usual. Set each column in order. Wait a second. 0, 1, 2, 3, 4. What? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. This is the last one we're missing. 2, 3, 4. 5, 6. Let's try to return this. Nope. Of course. So negative x, -1. Okay. Was I just looking at this chart wrong? That's what I thought. This is my idea from the beginning, right? Okay, let's submit it. And there you go. Passes all test cases. Again, I'm really glad that I was able to come up with my own solution to this question without any assistance and solve it on my own. So, yep, that's it for this video. Thank you for watching and stay tuned for more.